beta, small o, and small omega. Okay. Now there are some rules for rules means the properties for all these notations. So number one is the transitivity, rule of transitivity. What do you mean by transitivity? We know that if a equal to b and b equal to c, then rule of transitivity says that a will be equal to c. Okay. So whether these rules are applicable to this notation or not, we shall check it. Now you see Fn is big O of Gn and Gn is big O of Hn. These are given. Does it imply Fn is big O of Hn? Yes. Why? Because you see Fn is big O of Gn. It implies what? Fn is less than equal to C1 multiplied by Gn. Some constant. Okay. For all values of n greater than equal to n naught. We know. And Gn is big O of Hn. What does it indicate? It indicates that Gn is less than equal to some constant C2
C2 into HN.
Hn for all values of n say greater than equal to suppose n1. Now from these two I can write to check that Fn is less than equal to C1 into Gn, whereas Gn is less than equal to C2 into Hn. So I can write it C1 into C2 into Hn for all values of n greater than equal to maximum of n naught comma n1. Is it clear? Is it true or not?
Yes, sir.
Sir,
Yes,
can
sir.
you explain it once more, sir?
I am saying that Fn is less than equal to this is clear. Fn is big O of Gn definition.
Yes,
The
sir.
similarly Gn is big O of Hn. This is the definition. We shall take different constant. Don't take both C. It may not be C. So it is C1, it is C2. It is for all values of n greater than equal to n naught, and here for all values of n greater than equal to n1. Now here you see, can I replace this portion by this one? Because I know Gn is this. So if I
Yes,
place
sir.
this here, so I will get what? Fn is less than equal to C1 into C2 into Hn. Clear? Now for all values of n, what? Greater than equal to n naught or n1? That I do not know, but I know one of them will be maximum. Okay. Suppose this is, for example, it is greater than equal to 5, it is true. And suppose this is 7. If it is greater than equal to 7, this expression is true. So I shall take this expression is true for greater than equal to 7. That for all values of n greater than equal to maximum of n naught comma n1. N naught comma n1. Clear? So this implies what? This implies Fn, I can write like this, that's less than equal to some constant C3 into Hn. Okay, for all values of n greater than equal to say if n1 is greater than n1 n naught, suppose I can write like this. Fine. So here you see Fn. So from this definition, I can say from this equation, I can say that Fn is big O of Hn. This. So this is called rule of transitivity. Okay. So this is true. Similarly, you check Fn is theta of this and Gn is theta of this. So Fn will be theta of Hn. I am not showing the proof. The proofs are same. Similarly, big O notation. This also follows the rule of transitivity. Fn is big omega of Gn. Gn is big omega of Hn, and so that implies Fn is big omega of Hn. So in this way, small o, small omega are all these follow the rule of transitivity. Clear? Now, next rule of reflexivity. So reflex means you know that if any relation means reflection, you know a are present, that is called reflexive. There are some property in relation that you have already heard. Chana sir has told. So here you see this f both are present. Can I write Fn is big O of Fn? Yes. because I can write less than equal to, a function is less than equal to itself, equal sign is there. So okay, or you can write 2 if you want less than equal to, anyway, but that means what, this is big O of fn. Similarly theta n, similarly this rule of symmetry, rule of symmetry. See, fn is theta of gn, then I can write gn is also theta of fn. You know the definition of theta, that fn is less than equal to c2 gn greater than equal to c1 gn. So here you see I can write from this that gn is less than equal to 1 upon c1, that is another constant, and this is greater than equal to 1 upon c2, sorry, this should be fn. Just a minute, I'm writing, this will be fn, this portion, gn is greater than 1 upon c2 into fn. So here you see gn is less than equal to some constant into fn and greater than equal to some constant into fn. So therefore gn is theta of fn. So this is rule of symmetry. So rule of symmetry means, you know, a relation is said to be symmetric if AB is present, then BA should be present, like that. If fn, here gn, so here gn and fn. Rule of transpose. So you see fn is big O of gn if and only if gn is big omega of this, means big O and big omega, they forms the transpose. Small o and small omega, you see the definition, I am not showing, this is same. Fn is less than equal to c1 into gn, so I can write gn is greater than equal to 1 by c1 into fn. So that means gn is fn is the lower bound for gn. If gn is the upper bound for fn, so I can say that gn will be the lower bound of fn. Similarly this. Now very important rule for your problems, means during the analysis part. Here you see there are rule of sum and rule of product. This is very important. I am saying f1n, suppose a function of n is big O of g1n, and another function f2n is big O of g2n. Then the rule of sum says that f1n plus f2n is big O of maximum of g1n and g2n. This is called rule of sum, and this is called rule of product. f1n into f2n is big O of g1n into g2n. Clear? Now how can you prove? For example, for this part, f1n, or I can show here, you see, say f1n is big O of g1n, it has been given. So it implies here f1n is less than equal to some constant c1 into g1n. Similarly, another has been given that f2n is big O of g2n. So it implies what? f2n is less than equal to some constant. I have not written for all values of, you should write for all values of n greater than equal to n naught. Here for all values of n greater than equal to n1. Clear? Now if we multiply f1 and f2, I can write f1n into f2n will be less than equal to c1 into c2 into g1n into g2n for all values of n greater than equal to max of n naught comma n1. Right. So here you see this is another constant. I can write this as this portion as c3 suppose. So f1n into f2n is less than equal to c3 into g1n into g2n for all values of n greater than equal to max of n naught comma n1. Now this says what? This says us that f1n into f2n is big O of g1n multiplied by g2n. Now see, this is theoretical, completely theoretical. Now why there is maybe a question, why should we learn this rule of product? This is called rule of product. Okay, rule of product says that if f1n is big of g1n and f2 is big of g2n, then f1 n into f2n is big of g1n into g2n. So here you see, suppose you have written a code, suppose for say I equal to 1 to I less than equal to n I plus plus. Okay, here uh, another loop is there. Say here it is, you are written suppose a equal to b, say c equal to d plus a, like this. There are some statements. Similarly, there may be some statements that takes constant amount of time. Okay. Now here you see this loop. So what is the time complexity for this? These are constant takes. This takes constant time. Big O of 1, big O of 1. You know the RAM model. I have already said that assignment, addition, these all take constant amount of time. Constant. So now what will be the time complexity of this loop? You tell me how many times this is executed?
So n plus 1 times.
Anyway, so the it takes off, or its order will be big O of n. Clear? Now there are some statements, these are also suppose means constant take this portion there may be some other, another statement si is j. So suppose this takes also constant amount, right? So overall, or anyway, there may not be any statement. For simplicity I am not writing here, okay, for simplicity. So this is big open. Now this loop executes how many times? This outer for loop,
Big O of n.
big open. So if I ask you total time complexity, it will be these into this. You know already how many times these statements will be executed. If I ask you, this statement will be executed how many times? N square. This is n for I equal to 1, for I2 equal to 2, this will be again, this statement will be executed n times. For I equal to 3, this will be executed for n times, because j equal to 1 to n, you know. So n like this n times, so n square. So overall time complexity will be big O of n square. Okay, I am writing here big O of n square. Now what is this? This big O of, you see, check, big O of, this is g1n, this is g2n. So this will be total time complexity will be, this is embedded one within the other. So total time complexity will be big O of n into n. That means big O of n square. So this is the call the rule of product. Clear? Rule of product. Now rule of sum. What is the rule of sum? In this case, f1n plus f2n will be big O of max of G1n comma G2n, maximum of this. So that means F1n is big O of G1n and F2n is big O of G2n. If it is so, then it says that what? That F1n plus F2n will be big O of max G1n comma G2n. Okay, you can prove also similarly like this. I'm not showing entire details, just like this. F1n, this says that F1n less than equal to C1 into G1n for all values of n greater than equal to n naught, say. Similarly, this G2n for all values of n greater than equal to n1. Okay, here. So this, now you can from these two, suppose it may be the, so I know that either one of them will be true, larger, means one of C1 and C2 will be larger. Okay, so which one is larger? Suppose or let C2 is greater than equal to C1. Suppose C2 is greater than equal to C1. It may happen C1 is greater than equal to C2, but we are taking this, does not matter which one is larger. So I can write if C2 is larger than C1, you see, I can write the first statement. If it is so, can I write this, that F1n is less than equal to, since C1 is less than equal to C2, can I write this? Tell me, is it correct or not? If C2 is greater than C1,
No, sir, because in
why?
that case, that sir, because C2 is only associated to that particular G, like G2n.
See, just a minute, just a minute. If one function is less than equal to, what is C? Constant. It is suppose 5. And if it is 7. So if f1 is less than equal to 5 into some function, will it not be less than equal to 7 into that constant?
Yes,
For
sir.
all
Yes,
Yes,
sir.
values of, so it is correct. So I can write like this. Okay, for all values of n greater than equal to n naught. I am not changing it. Please check it. So from these two, I am getting this. F1n is less than equal to C2 into Gn. Okay. Now after these, see, these you consider these and this. Here, actually, I am writing in details. I thought that I will not write in details. Anyway, so from these, can I write that F1, and suppose, also suppose, okay, you can write like this, that F1n plus F2n is less than equal to, can I write C2, then G1n plus G2n for all values of n greater than equal to max of n naught comma n1. I can write this. Clear? Now suppose G1 in this case, say G1 is a quadratic function, means some n square plus 2n plus something, and this is some linear function, means say 3n plus 2, G2 is. So which one is the larger? G1. So if I from this, you see, in that case, means if G1 is the larger function, larger means its power is higher than this G2's, then which will be means the f1n and f2n will be determined by which function g1n, or if g2n is larger than g1n, then it will be means f1n plus f2n, the order of this function will be determined by the g2n, whichever is the larger. Clear? So from this I can say, you can take the, I think this proof is in the Coreman. Okay, in other books also you can see the proof. So it is some constant c, means c2 into max of uh, that sorry, don't write c here directly. I am writing this equal to big O of max of, if you write the big O, then don't write the constant c, but I have said already. Okay, or you can show in detail again, f1n plus f2n is less than equal to c1 some c2 into g1n if g2 is maximum, then g2 larger than g2. So I am writing just like this. Now this is theory, theoretically. That means the sum of these two functions is this. Okay, this is called the rule of sum. Now why we are reading this, why this is important? The reason is that suppose you have a code like this. Say you have code, you have written a portions, main functions. Okay, this is a lengthy code. Now there are some statements, say s1, s2, say s3, like this, say s10, s11, like this, it's going on. Okay, I am not right just showing all, say I am showing up to s20. Now suppose you know this its time complexity is big O of 1. Okay, big O of 1, it's, it may be s2 may be a for loop, if s it may be big O of n if s2 is a for loop which executes n times, like this, for I equal to 1 to I less than equal to n, I plus plus, a equal to b, and c equal to 2 plus a. Okay, suppose you are writing these two. So, it may be big of n, like this is an example. Okay, so it may be big of 1 like this. It is suppose big of 1 in this way. So what will be the time complexity up to this part? See, this is big O of 1, this is big O of n, this is big O of 1, this is in this way. There are 10 statement. So total time complexity for this will be
O of n, big O of
big
n.
O of n. So can I, that what is the meaning? So this is the maximum of all these functions. It is 1, it is n, it is 1, 1, 1, like this. Clear? So I am writing this is big O of max of all this. Okay, that means big O of n. So rule of sum. Clear? So actually you have, so whenever you would like to compute the time complexity part for a program or algorithm that you have written, you should take care of all the statements that is written within the code. Clear? In this way you will compute, and for that you need to take the help of rule of sum, means you take the rule of sums. Okay, and rule of means product also, that we have seen.
Sir, we only calculate the worst case time complexity.
Yes, yes, yes.
Okay,
Or
sir.
worst case. Otherwise, how can you say that it will be better than your competitor? Okay.
Okay, sir.
Now I'll show you another example, but before that, homework. Uh, you think I will not say. So prove the above theorem. It has been done. Now here you see is f1n minus f2n. You know the rule of sum says this. Rule of product says this. Means is it true that f1n minus f2n is big O of g1n minus g2n? I have not said. If it is true, you have to prove it. If it is false, then you just give an counter example. Clear? That's enough. That is sufficient to prove that it is wrong. Similarly, here also, if it is true, then you have to show that is correct by proving it. But if it is false, you just give an example to show that counter example to show that it is wrong. Okay. Now, next, here you see, suppose can you tell me a function fn which has some n, but it is big of 1. Okay, before that, you see, any constant c is big of 1. Why?
That is defined once only.
No. By mathematically, you have to show it. See, can I write this? That c, any constant c is less than equal to now c is constant. If c is constant, this is also a constant. So that means c is big of 1 by mathematical definition. Clear? So this is the proof that any constant c is big of 1. Fine. Now I am asking you that you find a function fn. You find a function fn which is big of 1. But I am not asking about c. C is a constant function, but I am asking a function that involves n in that expression. For example, fn is say fn is say n square plus 2n plus 3. But I know that this is big O of n square, and here n is also involved. Clear? So I am asking you a function fn, that I am not saying what will be this part, but that will be equal to big of 1.
Sir, something like 3n plus 2 by 4n.
3n
3n plus 2 divided by 4n.
just a minute, whatever you are saying, that 3n plus 2, then whole divided
By
or
whole divided.
whole divided by
4n. 4n.
4n. So you simplify it, means you are saying 3 by 4 plus 1 by 2n.
Yeah.
Now why it is big of 1?
Mm. The 3 by 4 part is constant, and 1 by 2n we can prove that it is less than O1, big of 1.
See, whenever you will prove, then never say that this is less than big O of 1.
Oh yeah.
It is wrong to say. You can say that it is less than 1. I can prove it is. I can prove that it is less than half. That is different thing. But you can't say that it is less than big O of 1. Actually, make it simple. Means you should simplify it. That I can write that if n is suppose 1 upon n, for example, and this is big O of 1. Why? Because if I make n larger, what happens? For n all values of greater than equal to 1, this fn will be always less than equal to what? 1. Suppose n is 2, so it is half. If n is 3, 1/3, so that is also less than equal to 1. So you see, this is, I am writing just 1 as 1 into 1. Why? Because I am taking this portion, this as the constant c constant, and this is 1. So fn is big O of 1. 1
Sir,
upon
so
n.
it can be 1 by n power anything, right?
Anything. But I am showing just give an example. What I said, that give an example. Example
Okay, sir.
can be okay. It is theoretically. Actually, it doesn't occur in the algorithm. Okay, mathematically, it is of mathematical interest. Clear?
Yes, sir.
Now, next, very interesting questions to you, all of you, is that we know a function follows the rule of transitivity. We have proved it. Now suppose, can we write that 2 to the power n is big O of 2 to the power n minus 1? This is my question.
Yes, sir. We can write
Yeah, we can write. How?
Yes.
2 into 2 to the power n minus 1.
Fine.
2 to the power n is
2
less
is,
than
yes, this. So therefore 2 to the power n is big O of 2 to the power n minus 1. Now 2 to the power, similarly I can write 2 to the power n is big O of 2 to the power n minus 2. Clear? Because since,
So C is 4 then.
yes, no, 2 to the power n minus 1 is less than equal to 2 into 2 to the power n minus 2. Why 4?
Oh, sorry. N minus 1. I thought it was with N, sir. Sorry, sir.
Clear?
So then
2 to the power n minus 2 is big O of, in the same reason. Clear? In this way I can write like this. Now suppose so in this way, can I write 2 is big O of 1, means 2 to the power 0 actually. You see, this portion is 2 to the power 1, means 2. So this is 2 to the power 0, means 1. Clear? Now if I apply rule of transitivity, I can apply rule of transitivity. So after, from this, if you apply the rule of transitivity, so here what shall I get? Using these two, 2 to the power n is big O of 2 to the power n is big O of 2 to the power n minus 1, n minus 2. This is this and this. Fn is big O of Gn, Gn is big O of Hn, so therefore Fn is big O of Hn. We have proved already. This is correct. Now you apply all this. So if you apply this, so what shall I get? That 2 to the power n will be big O of 2 to the power n minus 2, and 2 to the power n minus 2 is big O of 2 to the power n minus 3. So I can write like this. In this way I can write that this is equal to big O of
1.
1. Fine. So we have shown 2 to the power n is big O of 1. I have proved. But I know that this is wrong. It cannot be.
Yes, sir.
So where is the fallacy? What is the fallacy? I have proved.
Sir, it is only possible for a single case, sir.
No. Single case means?
Like when n
Sir,
is 0, then
so in the last case, I mean, 2 to the power 1, that's a constant. There is no variable term, so maybe that we can't consider.
No. This portion is okay. Correct. This portion is
Okay.
correct because this is this. I can write 2 is less than equal to 2 into 2 to the power 0.
Now, for rule of transitivity, we can't consider that one last part.
Last part means
2 to the
this
power
is
so
1
it's
goes
not
to what?
fulfilling the
No.
for all n greater than n not criteria, sir.
No. See, there is nothing wrong in the rule of transitivity. Clear? We have proved it. But please remember, while applying, you can apply rule of transitivity so many times. But please remember, when you are applying rule of transitivity, please take care of the fact that how many times you are applying the rule of transitivity. That does matter. Here, how many times you are applying the rule of transitivity? N times?
N times.
infinity
times?
is n
No, not
times.
infinity, not infinity.
N
N times.
times.
Okay. So just a minute, sir. So here what happens, you see, in this case that I am applying 2 to the power, basically whenever I am writing, the 2 to the power n is less than equal to 2 into 2 to the power n minus 1. Then this is equal to 2 into 2 into 2 to the power n minus 2, rule of transitivity. Okay, so similarly then 2 into 2 into 2 into 2 to the power n minus 2, or basically I can write the 2 square into 2 to the power n minus 2. Now here you see one thing, that whenever I am applying this portion, then it next part it will be 2 cube into 2 to the power n minus 3. Fine. In this way, this value is gets reduced. It is reduced, but this portion is increasing. Check it. So if you apply so many times, what will happen? Finally, that this portion. Just a minute. I am
It
writing here.
becomes 2 raised
2
to
to the
n.
power 2 to the power 0, sorry, this will be 2 to the power 0, and this becomes 2 to the power n. So actually this portion does not remain constant, you can apply fine, but this should be constant. If it is not constant, then how can you say that 2 to the power n will be big O of 2 to the power 0? Is it possible? This should be constant, but you are applying variable number of times. Are you getting? So actually you are applying n times very well. So that's why this constant becomes variable. It is depending on n. It should not depend on n. Otherwise, it will not remain constant. Clear? So that's why we cannot say that this will be 2 to the power of big O of 1. Is it clear?
Yes,
Hello?
sir.
Yes, sir.
Otherwise, what will happen? Suppose your friend, you know, say bubble sort, etc. Sorting. So you are sorting. For example, sorting algorithm. So you are writing an program nicely to reduce the time complexity to say big O of n log n. Now suppose your friend is saying that okay, you are giving some numbers, say 2, 4, 8, minus 8, 6, then 3, then minus 40, like this. In this way, you have given some numbers, and what he will say? He will say, I can sort in big O of 1 in constant time. What he will do? He is writing like this. You have given say n numbers. It's very large list. So what he is doing? Actually, your code has something like this. Say for I equal to 1 to I less than equal to n I plus plus. You have written so many things. There are so say merge sort or whatever sorting algorithm you have written. It is like this big O of n. Now what he is saying that okay, I will not write like this. I will just what I will do, instead of writing for I equal to 1 to n, see I can break this loop into say n times like this. Means this portion, suppose this is a statement s1, s2, for example I am saying s3. These are the three statements. Okay, so what he will say, that he will write like this: main, some statements are there, say s1, s2, s3, s1, s2, s3. S1, S2, S3. He will not write for loop. Please remember what he is doing. He is writing in this way so many times. Okay, his code will be very lengthy. Now he is saying, okay, you see, this is big O of 1, fine. Big O of 1, constant time, constant time. Okay, constant time. Now he will say, okay, apply rule of sum. Apply rule of sum. This will be big of 1, constant time, and these statements also big of 1 beyond. So in sorting text constant amount of time. Is it correct?
No, sir.
No,
No.
it cannot be. Actually, he is writing so many times. Means say he is writing, suppose say 1,000 times this statement. So it is not constant. It depends on the inputs. How many times you are writing. So otherwise, any program can be made to big of 1. So please take care of these facts. Clear? While designing the algorithm. Otherwise, anybody can say I can design the algorithm in constant time. It is not correct. So the same thing happens in this
Sir,
example.
what is the limiting condition in this case, sir? Sir, like how do like so I did not get what is the
I am
condition.
asking, I am saying that if any persons instead do not write any for loop, while loop, everything is removed and he is repeating so many times. That depends on the input. How many times you should write the S1, S2, S3? It depends how many list numbers are there in the input, and according to that he is writing. So that is variable part. If you are getting you are suppose providing a list of say 20 say 1000 numbers, then he need to write so many lines of codes. Is it a justification to say that it is big of one? No.
No, sir.
So that's why I'm saying whenever you will say that if somebody says that he has improved the time complexity of the algorithm, immediately you will say what? Please remember you. So that's why every scientist means whenever you are improving the time complexity of any existing algorithm, they also ask you what is the constant part. That is a factor, constant part. That means is it really constant or variable? That just like here. What you are getting here, you see that this part is not constant. This part does not remain constant. It should be constant. Otherwise, why means this will be 2 to the power n will be big of 1. This is wrong. Clear? It cannot be. Okay, you understood?
Yes, sir. Yes, sir.
So in next class means I will continue. Okay. So and please all of you, I am saying that you don't means become idle just